This presentation is to explain Lab 2 of Newton's laws. We are Group 4 of Period 4. Our question for this lab is how will different masses in the cart affect the acceleration of the cart? Going into this lab, we already know how Newton's second law works. Newton's second law is F equals to ma, F being the net force, m being the mass, and a being the acceleration. This lab tests how acceleration is affected by mass, so we can rewrite Newton's second law to say a equals to F over m. For this lab, we will use a pulley, weights, a ramp, string, a cart, and a computer. We also need to know how pulleys work for this lab. The pulley in the diagram is changing the downward pull to a rightward pull. The string is attached to weight y and the cart. When weight y is dropped, there is a force applied downwards. The pulley redirects the force so that the string pulls the cart to the right. We hope that this experiment gives us more information on how mass affects the acceleration of the cart. We think that when we add more mass to the cart, its acceleration will decrease.
Procedure. Step 1. Obtain all materials from instructor. Step 2. Set up the track on a level surface such as a desk. Step 3. Ensure that the side of the track with the pulley is towards the edge of the desk so that the weight can be hung from the string. Step 4. Hook up the motion sensor to the laptop. Step 5. Tie one end of the string to the cart and the other to a weight. Step 6. Remember to keep the weight of the hanging mass constant while changing the mass of the cart after 3 trials of each weight. Step 7. Make sure that the string between the mass and cart has no slack and is on the pulley. Step 8. The hanging mass should be touching the pulley and the cart should be pulled back as far back as possible. Step 9. Place the motion sensor directly behind the cart with about half an inch of space between the two. Step 10. Click the start button on the software of the motion sensor and release the cart when a buzzing noise is heard from the motion sensor. Step 11. Click stop when the cart has reached the end of the track. Step 12. Highlight all of the points before the cart stops on the graph and determine the acceleration. Step 13. Record the data into the data table drawn in the notebook. Step 14. Repeat steps 7 through 13 when changing the mass of the cart. Example of a trial. Notice that the sensor is placed very close to the cart. When the start button on the software is pressed, the person dropping the weight has to wait for the sensor to start buzzing to know when it has begun to track the cart's motion.
Conclusion. As seen in the graph provided, our claim is proven correct. Our claim was that if mass on the cart were to be increased, the acceleration of the cart would decrease. The decline in the measured acceleration trend line is close to being parallel to our predicted acceleration trend line. Though during the course of our procedure, we encountered a couple errors. Because of the force of the weight dropping, the ramp would constantly jerk forth. To fix this issue, we had to hold on to the back of the ramp. Another major error is the force of friction. Our data does not include the force of friction. That is mainly why it is so similar to the predicted trendline. For future investigations, we recommend replacing the metal ramp for a surface with less friction to receive more accurate and credible results.